Hey, Vsauce. Michael here. This is Earth, as seen from Saturn. That is us right there. And if you look closely, see this little protuberance? That's the moon. This image was taken by the Cassini spacecraft on July 19th, 2013 at 21:27 Coordinated Universal Time. The thing is, NASA gave the public advanced warning of when it would be taken, which means that this image of Earth was the first ever taken from space that some people on Earth were actually posing for. Our planet looks so small, insignificant, fragile. I recently attended the premiere of Sky One's upcoming You, Me, and the Apocalypse with some cool YouTubers, and it got me thinking. In the show, the characters find out that there are only 34 days left before a comet smashes into Earth that's likely to end humanity. They all react in different interesting ways, but what would I do if I found out that there were only 34 days of human history left? Okay, my first priority would be to get back to America to be with my family. But after that, I don't really have a bucket list, except that is exactly what I would want to spend my last few weeks doing, making a list to put in a bucket that I would then send far out into space away from Earth's impending vaporization. The list would contain information about us, all Earthlings, so that if libraries and monuments and YouTube videos were all destroyed, a record would still exist somewhere of what and who we were. Like a stone thrown into a lake, the ripples your life causes last long after you vanish. The tree you planted is climbed by future generations. The books you donated inform future readers. But what if it's not just your stone that vanishes, but the entire pond? Perhaps it's arrogance or vanity, but getting cosmic messages in a bottle out there before the end diversifies our archive and gives a better chance for future alien visitors, or whatever is left of humanity, to find out that we were once here, to show what we learned, maybe even to warn future life forms of what we did or what we didn't prepare for. We have already sent some messages about humanity out there beyond Earth, and if Earth is completely destroyed, those messages will be all that's left of us. What are they? Okay, first things first. How do you write something for the future? I mean, the distant future. The message might not be found for millions of years or billions. It might be discovered by an audience that's completely different, not only in language, but in senses. What if they can't see or hear or feel or taste or smell like we do? Or at all? What if their bodies destroy the very material we write the message on? What language do you even write it in? Well, in general, math and physics, which are believed to be the same everywhere in the universe, have been what we write outer space-bound messages in. Like the Arecibo message, written by Frank Drake, Carl Sagan, and others, which was blasted towards the M13 star cluster in 1974. It's composed of a semi-prime number of binary digits conveying some info about us, and it should reach the center-ish of the M13 cluster in about 25,000 years. At which point, if something intelligent lives there and detects it, they can respond, and their response will return to us another 25,000 years later. We won't be around for that, but Earth has also been broadcasting its radio and TV signals into space. Currently, it's about 200 light years in diameter. Compared to the Milky Way, it's about this big. Aliens within that bubble could tune in and listen to programs we sent out through our airwaves, but these signals thin out as the bubble expands. Across very large distances, they may be essentially impossible to tune into. Maybe a physical time capsule would be more permanent, but it can't be buried on Earth if Earth is about to be ravaged. A time capsule in orbit might be smart, like Lagios 1, a satellite put into orbit in 1976 that allows for very precise laser measurements of positions on Earth, but also contains a plaque designed by Carl Sagan, upon which is written the numbers 1 to 10 in binary, and the arrangement of the Earth's continents 250 million years ago, today, and their estimated arrangement in 8.4 million years, which is how long we believe the satellite's orbit will be stable. Drag caused by the thin atmosphere up where it orbits and influences like solar activity will eventually cause it to fall back down to Earth, but its plaque will serve as a time capsule, a message from us today to whatever happens to be alive or intelligent here on Earth 8 million years in the future. To put that in perspective, the pyramids were only built about 5,000 years ago. 8 million years ago, there weren't even humans on Earth. The latest common ancestor of humans and chimpanzees was around, though. 8 million years from today, when Lagios returns, what will intelligent life on Earth look like? If Earth's surface is barren of life at that point, Lagios 1 will be alone. But what about satellites in geostationary orbits? These orbits are far enough out that they're much safer from atmospheric drag and could remain above Earth much, much longer than satellites like Lagios. These satellites are our pyramids. They're smaller than monuments built by past civilizations, but impervious to anything that might go wrong on the less stable surface of our planet. If alien archaeologists come by in 1 billion years or so, these satellites may be what their alien encyclopedias use as the picture for the humans article. So far, we have erected about 450 of these geostationary monuments. When such a satellite wears down and ceases to be operational, it takes a lot of energy to slow it down so it can move out of the way and fall to Earth to burn up in the atmosphere. So instead, they're usually pushed into what's known as a graveyard orbit, a shell around the planet where they can be parked without interfering with important operational satellites. It's fitting that we call these graveyard orbits because tombs are often the most stunning things we have from previous civilizations. These graveyard orbits are tombs, in a way, not for kings, but for machines. Junkyards that will outexist the very societies and people they so largely define. Luckily, a few contain more than just our craftsmanship, they also contain a record. Like Echostar XVI, a communications satellite launched into geostationary orbit in 2012. Aboard it is a silicon disk created by artist Trevor Paglen containing 100 images of Earth and Earthlings. Now, unlike Lagios, Echostar XVI will likely remain in orbit for billions of years, safe from discord and change down here. But here's the thing. What if our entire solar system is lost? Or what if life out there doesn't decide to ever visit our system? Well, in that case, we have sent interstellar messages. At this moment, so far, there are 11 distinct human-made things on trajectories out of the solar system into interstellar space. They're all related to 5 probes: Pioneer 10, Pioneer 11, Voyager 1, Voyager 2, and New Horizons, the thing that recently made a Pluto flyby. These objects are our most distant hellos. Over the next 10,000 million, billion years, they'll pass close enough to other star systems, maybe even planets, to possibly be discovered by other intelligent life forms. We had the foresight to include special messages on these probes. The Pioneer plaques are attached to Pioneer 10 and 11, which, launched in the early 1970s, were the first human-made objects to ever be sent on a trajectory to not just leave Earth, but to leave the solar system entirely. If discovered by other life out there, these plaques, designed by Frank Drake and Carl Sagan, could be our first chance to say, "Hello, we exist." Or, depending on how long humanity lasts, our only chance to say, "Hello, we existed. This is what we were." But will the plaques make sense to aliens? Many human scientists have had trouble deciphering their meaning, but here's what they say. At the bottom is a map of our solar system with a path showing the Pioneer probe itself and where it came from. This element has been particularly criticized for being human-centric. I mean, an arrow? Who's to say aliens will know that this depicts a path and not some structure in our solar system? Also, it's an arrow. Arrows might convey "this way" only to civilizations that hunted or developed pointy projectiles. Anyway, up here we define units. You can't tell aliens about humans or Earth by using seconds, kilometers, or light years, because we made those measurements up. Instead, the plaque uses hyperfine transitions to communicate distances and time. The hope is that curious, intelligent life forms who find this will understand that this is a hydrogen atom. One proton, one electron. Hydrogen is the most abundant element in the universe, so hopefully its properties will be a common point of understanding. Now, sometimes, if you've got enough hydrogen around, you can catch atoms in the heap transitioning between particles with parallel spins and anti-parallel spins. Now, whenever this transition happens, electromagnetic radiation is released with a period of about 0.7 nanoseconds and a wavelength of about 21 centimeters. It's hoped that aliens equate this tick mark with these two units of measurement. For example, the woman is said to be, in binary, 8 of these units tall. 21 centimeters times 8 is 168 centimeters. You would think that putting the probe itself behind them for scale would be enough to show our size, but having both might help solidify the connection. This diagram is meant to show where we live. We are in the middle. The direction and proportional length of the lines show where distant pulsars are. A tick mark near the ends of each line shows the third direction, behind or in front of the plaque, that the line should go in. In binary, next to each line is the period of each pulsar, again in the time units described above. If aliens make this connection, they could possibly match the periods with the correct pulsars in real life, triangulate our position, and come say hello. Also, since the period of a pulsar changes over time, they could use our observed periods to date back how long ago this plaque was made. So that's how the plaque works. It kind of feels like we're just sending out a bunch of science homework to space, but how else can you find common ground with something that might not resemble you in any way you could even imagine? Despite heading out first, the Pioneer plaques are not the first physical messages made by us to go interstellar. That title belongs to Voyager 1. Currently moving at 17 kilometers per second, it is the most far-out thing humans have ever made. Literally. In about 40,000 years, both Voyagers will pass within less than 2 light years of other stars. If aliens find them, or if future humans find them, a golden record is attached to both that contains information about humanity. The record is made of gold-plated copper with an aluminum cover containing some uranium-238. Given its half-life, smart aliens could analyze it to determine how long ago the record was made. On the record is the inscription, "To the makers of music, all worlds, all times." The record contains 116 images, as well as audio and video recordings of humans, animals, songs, and greetings in 55 languages. Printed on the record are instructions for playback and info about us. The hydrogen hyperfine transition unit definition and the pulsar map included on the Pioneer plaques, but the record also comes with a stylus and platter to play it. Instructions for using the stylus are on the record. This is a picture of the stylus being used correctly, and then in binary, using the transition units, the record tells the aliens that the stylus should go around the record once every 3.6 seconds to play back correctly, and in total should take about 1 hour to do so. For the video portion, instructions are given in a circle. The first video image is displayed so they know they did it right. Also included on the record is a message from then President of the United States, Jimmy Carter. There's something vulnerable about the message. It's delivered to an unknown recipient, like when someone in a horror movie asks into the darkness, "Is anyone there? Hello?" This is what it says. "We cast this message into the cosmos. It is likely to survive 1 billion years into the future, when our civilization is profoundly altered and the surface of the Earth may be vastly changed. Of the 200 billion stars in the Milky Way galaxy, some, perhaps many, may have inhabited planets and spacefaring civilizations. If one such civilization intercepts Voyager and can understand these recorded contents, here is our message. This is a present from a small, distant world, a token of our sounds, our science, our images, our music, our thoughts, and our feelings. We are attempting to survive our time so we may live into yours. We hope someday, having solved the problems we face, to join a community of galactic civilizations. This record represents our hope and our determination, and our goodwill in a vast and awesome universe." Are these messages enough? Should we send more? Well, why not send everything? We could if we sent the Library of Babel. It's a website built by Jonathan Basile that currently offers everything that has been or could be written. Seriously, divided into pages, it is built to produce and locate on demand any 3,200 character combination of English letters and the comma, space, and period. Basile has organized it all into hexagon-shaped rooms, each with 4 walls of books containing 5 shelves with 32 volumes of 410 pages each. Everything's arranged in a pseudo-random fashion, so browsing the online library feels like a treasure hunt. Here's how it works. Each page is given a unique sequential page number in base 10. The text on each page is encased inside this number. An algorithm Basile created uses the page number as a seed to generate a unique big number. That output is then converted into base 29 so that it can be represented using every letter in the English alphabet, as well as the comma, the space, and the period. This is what you see on the page. Basile has made sure that the algorithm will produce every possible combination, and the same page number will create the same output every time. Which means that what is on each page is already predetermined. So, in a way, every page already exists. It only needs to be looked up. And here is the really mind-blowing thing. The contents of a page can be converted to base 10, sent through the inverted algorithm, and turned into the exact page number they're found on. It's a truly eerie experience, because you can find the permanent location for any 3,200 character text. You can find in this library the description of your birth, every possible description of your death, every poem, every joke, every lie, anything that could be said can be found on this site. This thing blurs the line between invention and discovery. Did you really discover or invent that thing if its description already existed? 10 to the 5,000 different pages are offered by the Library of Babel. In comparison, there are only 10 to the 80 atoms in the observable universe. I searched for what I've just said, and sure enough, in this hexagon, on this wall, this shelf, in this volume, on this page, it's there. Hello. But deep down, we feel like there's a difference between this program permuting something unknowingly and a person actually meaning it, intending it, saying it because they wanted to with agency. We use a finite number of symbols to say things. For that reason, a library of every finite combination of those symbols can be made. But just because it can be made doesn't mean it has been said. That is the power we have. Perhaps you and I were born too late to explore the world and too early in history to explore the stars, but we were born at just the right time, which is pretty much all times ever, to explore language, to explore what can be said. What should be said? What should we send out to space? What that can be said will you be the first to say? And as always, thanks for watching.